And today I'm excited to tell you that we've put together a special and super easy to understand science report about the universe based on the newest research. What we have is truly one of a kind, and for the first time, a complete story about how the universe began, made from things we already know, but shown in a way you've never seen before. This is the first complete masterpiece about the birth of our universe. Many people don't realize how amazing our place in the universe really is. You probably don't know me, but I'm like the president of the universe. My job is to make sure everything runs smoothly. From the Big Bang until now, I make sure that the universe's energy, which you might call God, puts all its parts together perfectly. Trust me, it's a show way better than any reality TV. My ladies, my lords, people of the galaxies, kings and queens, Lord of Lords and everyone else, welcome to the report from the universe. Today, Stardate 2025, I'm not speaking as the president of just one planet, but as your president of the universe. I've been given the secrets to understand the universe, to share them with you when you're ready. It's a big honor for me to give this, for the first time ever, full report from the universe. From where I watch, I see everything. Galaxies dancing in the dark, new stars lighting up, and old stars fading away. I see you, looking up at the universe from this blue planet. You ask the big questions. That's what makes our universe alive. Running the universe is a big job, but often it's just about watching everything happen. The last year, or the last few billion years, has been busy. Things expanding, stars forming, and amazing supernovas. Because of these star explosions, there are lots of heavy elements. The basic rules of physics are steady. Gravity keeps everything together, and the speed of light is still the fastest anything can go. This report looks back, gives an update, and shows what's coming. Let's go on a trip together, back to the start, to when everything first began. We'll see how everything came from nothing, how energy turned into atoms that make up you and your world. This isn't a boring science class, but the ultimate family story, the story of all of us. From the smallest part of an atom to the biggest group of galaxies, we are all part of a huge connected universe. How you see things matters a lot. What looks messy actually has a hidden order when you look from far away. You see stars and planets. I see the invisible strings of gravity that connect everything. You feel the sun. I see the huge reactions making energy happening everywhere in space. The rules of the universe, from tiny particles to huge galaxies, are simple, beautiful, and you can figure them out. You discover them bit by bit. That's the best adventure of all. Sit back, relax, and enjoy the State of the Universe address. Well, let's talk about the beginning. Many of you will have heard of the Big Bang. That sounds loud, explosive and chaotic, doesn't it? Like cosmic fireworks. But I'm here to clarify something. The birth of our universe was not an explosion at all. It was a silent birth. Imagine a single point, smaller than the smallest speck of dust, containing all the energy that would ever exist. There was no space for expansion because space itself originated at that moment, and there was no air for sound waves to travel through, so it was completely and profoundly silent. It was an event of pure, concentrated energy, an impossibly hot and dense state unfolding in absolute silence. This initial state was what we might call a cosmic primordial soup. It was a soup of pure energy. Everything we see today, the stars, the planets, you, me, this report, it all started right there as potential. In this incredibly hot environment, there was no distinction between matter and energy. They were one and the same, constantly transforming into each other. Imagine it like steam, water and ice. Everything is H2O, just in different forms depending on the energy level. In the beginning, the universe was so full of energy that matter as we know it could not exist. Perhaps you're wondering, how can matter even arise from something like sound or light? It's simple. Sound is a wave that vibrates through a medium like air, but in the early universe there was no air, and thus no sound. However, energy can appear in various forms, as waves, like light, or as particles, like matter. When energy is highly concentrated, it can transform into light. These are electromagnetic waves, and if even more energy is present, this light can even be converted into particles, that is, matter. It's like a cosmic magic trick. Pure energy first becomes light, and then light eventually becomes matter. So the universe conjured matter from energy, first as light, then as matter. It was a state of pure, unleashed potential. As the universe began to expand, it also began to cool. This is a crucial point. Just as steam condenses into water when it cools, the energy of the early universe began to condense into the first fundamental particles. This is where the famous equation comes in, E equals mc squared. It is the universe's most fundamental recipe. Energy can be converted into mass, and mass can be converted into energy. As the universe expanded and cooled, a tiny fraction of this initial energy transformed into the first matter particles. Quarks and electrons, the fundamental building blocks of everything, began to emerge. It was the first and most important act of creation, transforming pure light into tangible substance. Approximately 380,000 years after this silent birth, the universe cooled enough for something magical to happen. Electrons could finally bind to atomic nuclei to form the first stable atoms, primarily hydrogen and helium. Before this moment, the universe was a hazy, opaque plasma. Light particles, called photons, could not travel far without colliding with a charged particle. But as soon as the neutral atoms formed, the universe suddenly became transparent. The light that was trapped in the fog was released and has been traveling through the cosmos ever since. We can still see this light today. It is called the cosmic microwave background radiation, and it is literally the birth of our universe. So, now we have the first picture of our universe, or the canvas, the cosmic microwave background. It shows us a universe that was smooth, but not perfectly smooth. There were tiny, barely noticeable changes in temperature and how dense things were. These small ripples in the fabric of space-time were the seeds for everything that would come. Imagine these are the first instructions in the universe's cookbook. Where it was a bit denser, gravity had a bit more to do. Over millions of years, these slightly denser areas started to pull in even more matter. This is the slow, patient work of gravity, the universe's master sculptor, gathering cosmic dust and gas into bigger and bigger clumps. Now, let's talk about light and sound. These are very different things. Light is an electromagnetic wave. It can travel through the emptiness of space. That's why we can see distant stars. Sound, on the other hand, is a mechanical wave. It needs something to travel through, like air, water, or a solid object. It's a vibration. In the endless empty space, there is no sound. A supernova might be an unbelievably huge explosion, but it happens in complete silence. This difference is important. The early universe was a place of light, but not a place of sound as we know it. The story of the universe is written in light, not in echoes. Still, here on Earth, there are fascinating and strange connections between light and sound. Have you ever heard of sonoluminescence? That's a really weird thing. If you hit a tiny air bubble in a container of water with strong sound waves, something amazing happens. The sound waves make the bubble get bigger and then violently collapse. When it collapses, the gas inside gets so hot that it gives off a tiny bright flash of light. You are literally turning sound into light. This shows that under the right conditions, different forms of energy can change into each other. It's a small example of the universe's incredible flexibility and how everything is connected. This idea of changing forms is key to understanding where we came from. The idea that energy can turn into matter, as described by E equals mc squared, isn't just a theory, it's why we exist. Scientists do this all the time in particle accelerators. They smash particles together at incredibly high speeds, creating a burst of energy that then forms new, heavier particles. The early universe was like the ultimate particle accelerator. The huge amount of energy from its beginning turned into the matter that now makes up galaxies, stars, and planets. Every atom in your body is a tiny piece of frozen energy, a leftover from that first moment of creation, quiet and unbelievably powerful. After the universe became clear, it entered a time called the Cosmic Dark Ages. For millions of years, there were no stars, just huge clouds of hydrogen and helium gas floating in the dark. But gravity kept working hard. The tiny changes in how dense things were, which we talked about earlier, kept pulling matter together. Slowly but surely, the gas clouds got bigger and thicker. As they squished down under their own weight, the pressure and heat in their centers shot up. This was like quickly pushing down on a bike pump. The air inside gets hot. The same thing happened in these first gas clouds, but on a much bigger scale. Eventually, the centers of these collapsing clouds got so hot and thick that something new and amazing happened: nuclear fusion. The huge pressure forced hydrogen atoms to join together and become helium, letting out a massive amount of energy. This energy pushed outwards, balancing the pull of gravity inwards, making a steady glowing object. The first stars were born and the cosmic dark ages ended. These first stars were huge, hundreds of times bigger than our sun. They burned at super high temperatures and lived fast, amazing lives, lighting up the young universe for the first time with their bright blue light. These stars are like the universe's giant workshops. They are space factories that take the simplest stuff, hydrogen and helium, and cook them into heavier stuff. In their glowing centers, fusion reactions create things like carbon, oxygen, and nitrogen. These are exactly the things needed for life as we know it. Every carbon atom in your DNA, every oxygen atom you breathe, was made long ago in the heart of a star. As the famous stargazer Carl Sagan once said, "We are made of stardust." That's not just a nice saying, it's a real science fact. Through its stars, the universe made the basic stuff for its own future complexity. But what about the really heavy things like gold, silver, and uranium? Regular star fusion can't make them. For that, you need an even more dramatic event, a supernova. When a huge star runs out of fuel, it can no longer hold itself up. Its center suddenly collapses and then bounces back in a giant explosion that can briefly shine brighter than a whole galaxy. The energy released in this explosion is so huge that it makes all the heavier elements on the periodic table. These newly made elements are then thrown into space, making the cosmic clouds richer, from which new stars and planets will form. Every gold ring and every piece of silver jewelry is proof of the violent end of a massive star. Well, let's get to the really mysterious part of my report. For a long time, we thought we had a pretty good idea of what the universe was made of. We counted all the stars, gas, and dust we could see and thought that was most of it. But we were wrong. It turns out that everything we can see, everything we've talked about so far, the stars, the galaxies, you, me, makes up only about 5% of the universe's total stuff and energy. So what about the other 95%? This is where the invisible players on our cosmic stage come in, dark matter and dark energy. They are the secret bosses pulling the strings behind the scenes. Let's start with dark matter, which makes up about 27% of the universe. We can't see it. It doesn't give off, take in, or bounce back light. So how do we know it's there? We see how its gravity affects things. When we look at galaxies, we see that they spin much faster than they should, based on how much visible stuff they have. Without more invisible stuff, these galaxies would just fall apart. Dark matter gives this extra gravity. Imagine it like an invisible cosmic frame or a giant invisible net. The visible galaxies are like dewdrops hanging on this net, showing us its shape. Dark matter is the quiet helper that holds everything together. We still don't know what dark matter is made of. It's one of the biggest puzzles in today's science. Scientists are looking for it in deep underground labs, trying to catch a glimpse of a dark matter particle as it passes through their detectors. It's a tough search for something we can't see, but it's needed to truly understand how our universe is put together. This invisible stuff clumped together in the early universe, forming the gravity wells that normal matter fell into, eventually making the galaxies we see today. Without dark matter, it's likely none of us would be here. It is the unsung hero of how cosmic structures formed. Then there's the biggest player of all, dark energy. This mysterious force makes up an amazing 68% of the universe. If dark matter's job is to pull things together, then dark energy's job is to push them apart. In the late 1990s, astronomers found out that the universe wasn't slowing down its expansion, as everyone thought it would. In fact, it's speeding up. Something is acting like a cosmic gas pedal, pushing galaxies apart faster and faster. We call this something dark energy. It seems to be a feature of space itself. The more space there is, the more dark energy there is, and the faster the expansion gets. It's the ultimate turbo boost for cosmic expansion. My universe is indeed expanding forever, pushed by this dark energy. In this growing space, the stuff and energy that are already there are spreading out more and more. It's true that new, heavier things keep forming in my stars, and yes, even now, energy can turn into stuff. But this is more like a constant circle and spreading out of the materials I gave at the start. The amount of sound waves, and light, photons, in the universe is huge, but it comes from the stuff and energy that are already there. Come back tomorrow for the President, the universe, and I, because the universe is my best work.